This is Geometry Lesson 8-2, Finding Angle Measures. I'm your host, Mr. Sindel. Let's see how to do an inverse. So this is kind of the main thing that I'm looking to do today. How do we undo trigonometry? And trig for short, because we can't say it, right? So the word undo is very informal. The word that I prefer to use is find the inverse. So I'm going to write inverse above here. How do we find inverse trig? So for example, if I have this equation, I gave some room here and I'll talk about that in a little bit. If I have sine of some angle is equal to 3/4, this is a ratio that we set up from 8-1's homework. If I say this, is there some way that I can undo sine to get this theta isolated? And hopefully you're okay with this letter theta. It's a Greek letter. Typically speaking, when we have angles inside of a triangle or inside of any shape, really, angles are typically lowercase Greek letters, and I just want to talk about that real quick. The three main Greek letters that we use for our angles are these three. I have them in the wall in my classroom as well, but this is the Greek letter theta. So over here I'm going to say that this is theta. This is known as alpha, and this is known as beta. I'll try to use these more often when I can. Most of the homework today just has a question mark because I'm being lazy. But again, the question, how do we isolate that variable? This variable might as well be an x, but I call it theta so you know it's an angle. And to do an inverse, it's worthwhile talking about inverses in general. So the inverse of x plus 1 is x minus 1, because the opposite of plus 1 is minus 1. The opposite of minus 2 is plus 2. The opposite of divide by 3 is multiply by 3. The opposite of divide by 4 is multiply by 4 is divide by 4. This one is a tricky one. Like the opposite of x squared is the plus or minus square root of the x. So now the question is, what are all of these? And I could have made this list a lot longer. I didn't have any exponents or logarithms or anything like that. But to undo a sign, the way that we undo it is we say that this is the arc sine of the angle. Similarly, cosine is the arc cosine of our angle, and tangent is the, I don't know how to spell apparently, arc tangent of our angle. On a calculator, you will not see these buttons because this is way too long to put on a tiny little button. So instead, the calculator will have this notation where they'll say sine to the power of -1. So that's the button that you're looking for, or they'll have cosine to the power of -1. That will be the other button. Or they'll have tangent to the power of -1. These mean arc tangent, arc cosine, arc sine. This notation, by the way, is absolutely terrible. Let me go on a brief tangent to talk about why it's terrible. Because by default, and here, let me do my tangent on why this sine inverse notation is terrible. So, when you see a power of a -1, usually it means this. It means like if I have x to the power of -1, that means do 1 over x. Or if I have 2 to the power of -1, that means go 1 over 2. Or if I have a fraction like 3/4 to the power of -1, it means flip the fraction, change it to 4/3. So you would think by default that sine to the power of -1 means 1 over sine. And that kind of makes sense, right? Because I've had students in the past ask, well, Mr. Sindel, to get rid of sine, here, I know what to do. Sine is being multiplied by this theta. So to undo the multiplication, you simply divide by sine on both sides. And to that I say, great intuition, and that even matches with this, right? 1 over sine means I'm dividing by sine. However, both of those are incorrect, and that's super frustrating to get that wrong. You cannot divide by sine of theta because this is not multiplying by sine. This is saying sine of this angle. This is saying, hey, this angle, I want to know what is the ratio of the opposite to hypotenuse. There's no way to say undo the ratio of opposite to hypotenuse, so you cannot do this. Please erase that if you wrote that in your notes. You cannot undo by dividing by sine. And similarly, and this is where I'm definitely going to cross it out, this is not true. What is true is that sine to the power of -1 is actually what's known as a function called cosecant, which is a function that I will not ever talk about in geometry if I can avoid it. Instead, we say that Sine, yeah, I have to be careful now because now my notation is bad. And I have to say that if I do want to divide by sine, if I want to say 1 over sine 1 over sine is cosecant, wherein sine to the power of -1 is not 1 over sine, it is just arc sine, which is super dumb, but whatever. I'll show you how to enter this in my calculator in just a sec. So let's finally answer this question. How do we undo this thing? So to undo sine, I'm going to take the arc sine of both sides. So here's my work. I'm saying take arc sine of the left-hand side. I'm doing that so arc sine and sine cancel out. Just as if I had x squared and I took the square root of that, they would cancel each other out as well. These two things cancel each other out, and you are left with just our theta, and we'll have some sort of approximation here. So anything that I do to the left, I also have to do to the right. So if I do arc sine on the left, arc sine to the right as well. And this is something that would, back in the day, you'd have a giant textbook that would tell you, what is arc sine of 3/4? And you look it up in your table and you'd be like, it's this decimal. Luckily now we have calculators. So let me go ahead and split my screen so I can go to my scientific calculator. Let's move that over here to the side. Let's go ahead and clear everything. So over here, I'm just gonna come over here and I'm gonna literally type in arc sine, and you can see, okay, so right there, you can see that the text is italicized, and then as soon as I type in the end, it's not italicized, it's like normal text. That means I have identified it as a function, and you're gonna type in the fraction here, 3/4. And this is going to be approximately, let's go ahead and write it in, 48.590. So in this homework assignment, we are going to round to the nearest whole degree, which means in my case, my theta is going to be rounded to just 49 degrees. And I have to be careful here because now that we're in this unit, it's really important that we know the difference between the two different units of angle measure. Just like you can measure length using meters or feet, you can measure angles using degrees, which is what I'm going to write right here, or radians. If you don't see this degree symbol, you assume that it's radians. So it's super important that you always have this degree symbol. And just as a note on the calculator, if you want to go faster and you have like a touch screen and you don't want to type in arc sine, you can go to the function tab, and then there's that sine to the power of -1 that I can touch, and then you can come back in here and type in 3/4. And it's the same exact answer. You can see they are synonymous on the calculator. So that's enough of the calculator for now. We'll come back to them later. I think that's all the notes that we need for now. Let's go ahead and jump into 2 examples. All right, so how do we even solve one of these? This is very similar to what we're going to see on the homework. The first thing that you need to do is to set up your trigonometric function. To do that, you are using your good old friend SOHCAHTOA. So to use SOHCAHTOA, we are going to identify our angle of reference. In this case, it's this top right angle. And I'm going to label my O, H, and A around my triangle. On the opposite side of my angle of reference, I have my opposite side. On the opposite of my 90-degree angle, I have my hypotenuse. And the remaining angle is the adjacent, aka the leg that is close to this angle that is not the hypotenuse, the neighboring angle, or the neighboring side length, I apologize. So what do I have here? The best way that I have to describe which of these trig functions you're supposed to use is identify which one you are not going to use. I'm not going to use h, cross off the h, which means inside of SOHCAHTOA, cross off the h's because we are not using the hypotenuse. You can see that this TOA part of SOHCAHTOA is the one that we're going to be using because none of its letters have been crossed off. So I'm going to use tangent. So let me write it out. I'm going to say tangent of my angle. You can use question mark if you want, but if you want to be cool like me, you can use theta and lowercase Greek letters like the rest of mathematicians. You can say tangent of this angle theta is equal to the ratio of opposite over the adjacent. The opposite in this case is 108, the adjacent is 29. So I'm going to set up a fraction, and don't write this down yet, 108 divided by 29. Here's why I told you not to write this down. What I'm about to do is I need to undo tangent. So what I really need to do is I need to really move this over a little bit because I need to give myself some room here to write arctangent. If I'm going to write arctangent right here, I need to be able to write arctangent right here. There's not a whole lot of room for me to write that. So I'm going to take this 108 over 29. I'm going to move this using technology. So now I have room to write out my arctangent. I can do that to both sides. I'm going to say arc, oh, I can't spell apparently, arc tangent of my left side. And if I do it to my left side, I also do it to my right side. So arctangent of both sides, and that will, again, cancel out my tangent. That's what it means to be an inverse function, leaving behind my theta, and then I'm going to use my calculator to figure out what arctangent of 108 over 29 is. And I do realize I didn't really write that down in the notes, so let me go ahead and write this down in the notes where I say this, this thing right there, right here, I'm going to change this to blue. You need to use a calculator. Use a calculator in order to find what that is. So I'm going to use my calculator to find what is arctangent of 108 divided by 29, and I'm going to round to the nearest degree. So again, split my screen, and then let's pull up my scientific calculator. And what do we have here? So I'm going to type in, I'm just going to hit the tangent to the no, I'm not going to do that. I'm going to hit enter first so I can go to a new line. Now I'm going to hit tangent to the negative first to type in arctangent, and then I can do 108 divided by 29. I have a touchscreen, so it is faster to type it out that way. And I'm going to write out my answer. This is 74 point, oh, I want to do this in red though. I like my colors. Okay, 74.970 if I'm rounding it. And I need to round it to the nearest whole number. So theta in this case is actually going to be equal to 75. Again, I need to have degrees here so I don't mistake this for radians. We'll talk about the difference between radians and degrees in another lesson here shortly. All right, first problem done. Let's try the next one. All right, so again, I need to figure out which trig function should I be using. And you might be able to get it already because you're a master at using your SOHCAHTOA. I'm going to write it all the way out just to make sure that everyone can follow me. So again, I'm going to write out SOHCAHTOA. And then I'm going to label. On the other side, on the opposite side of my 90-degree angle, I have my hypotenuse. On the opposite side of my angle of reference, I have my opposite side. And then default, must be the adjacent. And I'm not using the opposite side. So I'm going to cross off. I'm not using the opposite because there's no measure here. There's no number here. So I'm going to cross off my O, cross off my O. Okay, the only function that was untouched is this ka of my SOHCAHTOA. So I'm going to say, I'm going to do cosine of my angle. I'm going to use theta again, and that's going to be equal to, remember, give yourself some room in order to take the arc cosine of both sides. I'm going to write my angle right here. I'm going to say adjacent over hypotenuse. Adjacent over hypotenuse is 16 over 27. I'm going to write out my 16 over 27, and then I can get ready to undo cosine by taking the arc cosine of both sides. So I'll write out arc cosine of the left and arc cosine of the right, and the left side arc cosine and cosine cancel each other out, leaving behind your theta. What is that going to be? And I'm going to just pretend that I was on a keyboard and I would type out arc cosine of 16 over 27, and that's going to be roughly 53.659. Rounding to the nearest whole number, that's going to be 54. Both those are in degrees. Don't forget our units in this case, and box your final answer after we've rounded to the nearest whole number. Excellent. Well, that concludes the notes for 8-2 for geometries finding angle measures. Thanks for watching.